Welcome to qnawire.
We need to prove that the angular momentum about a point O dot the angular velocity of a rigid body is equal to 2 times the kinetic energy of that rigid body. And we also need to show that the angular momentum, the angle between the angular momentum and the angular velocity is less than 90 degrees. So we're going to start solving or proving this first equation. So we'll start by writing the equation for the angular momentum about some fixed point O. So we have the I component. Now for the J component, and we'll now have the K component. And next we'll write out the equation for the angular velocity. So that's just going to be the X component I plus the Y component J plus the Z component K. So we can now write that h of 0 or h of O times the angular velocity is equal to the angular momentum h of O dot the angular velocity vector. And expanding this, and I'll write it out in green. So we're going to expand this as h of O dot W, and then the dot product of this will be the following. Okay, so this is the total dot product of h of O dot the angular velocity. So we're going to simplify this into just a few terms. So simplifying this out, we'll get I of x times omega squared of x plus I of y times omega squared of y plus I of z times omega squared of z, and then minus 2 times I of xy times omega x times omega y minus 2 times I of xz times omega y times omega z minus 2 times I of xz times omega x times omega z. So now that we have this, and knowing what the kinetic energy is equal to, we can now write that h of O dot omega is equal to 2t. So next we'll prove that the angle between h of O and omega is acute, or less than 90 degrees. So from the dot product, we can say that h of O times omega is equal to h of O times omega times the cosine of theta. So from this, we can write that the cosine of theta is equal to 2t divided by h of O times omega. Since we know that this equation up here is also equal to 2t. And from this, so this expression on the right side, we know that this kinetic energy, this angular momentum, and this angular velocity has a value that's greater than 0. So from this, we say that the cosine of theta is going to be greater than 0. So we can now say that the angle theta is going to be less than 90 degrees.